Okay, this video is going to cover something called molecular formula. Molecular formula is similar to empirical formula, however, it's called the true actual formula. I don't know if you remember the nuts and bolts lab, but you guys made a couple different molecules, compounds, if you will, like this one right here. This is bolt nut, BTNT. And when you did this, you were supposed to find the percent composition by mass, and when you found for bolt nut, I got it to be around 65% mass of bolts and 35 mass percent of nuts. Okay. When you make bolt 2 nut 2, or BT2 NT2, it looks like this, and notice that it had the same percent composition, 65% bolts and 35% nuts by mass. Okay, so notice that it still has the same empirical formula. It's still a 1-to-1 ratio. However, its actual formula, its molecular formula, is BT2 NT2. So what's going to be the difference? What if you couldn't see these screws or these nuts and bolts? What if they were invisible and you couldn't tell them apart? So how are you going to tell the difference if they both have the same empirical formula? Well, remember that bolt nut weighed 3.740 and BT2 NT2 weighed twice as much. So they're going to have the same empirical formula, but their molecular weight is going to be different, twice as much, or its molar mass is going to be twice as much. So if I look at this problem here, it says during excessive physical activity, lactic acid, which has a molar mass of 90.08 grams per mole, forms in the muscle tissue and is responsible for muscle soreness. Elemental analysis shows that this compound contains 40% carbon, 6.7% hydrogen, and 53.3% oxygen by mass. What is the molecular formula of lactic acid? Well, you guys remember that if you're solving for empirical formula, you drop the percentage, and you write grams, grams, and grams. Then you convert grams to moles, grams to moles, grams to moles, and then you divide them all by the smallest number to get your mole to mole to mole ratio. And when you do that, you get CH2O. However, when you add up the molar mass of CH2O, it doesn't weigh 90.08 grams, it weighs 30.03 grams per mole. So I'm looking for a formula that has the same empirical formula as CH2O, but it also has a mass of 90.08 grams per mole. So I want the same 1-to-2 to 1 ratio, but I want it to notice this weighs what? 3 times more. So I'm looking for a molecular formula that has a 1-to-2 to 1 ratio, but weighs 3 times that. So how about C3H6O3? Notice that all I did was take my 1-to-2 to 1 ratio and I simply multiplied it by 3. So now I have my 1-to-2 to 1 ratio and it weighs 3 times as much. It weighs 90.08 grams per mole. So the molecular formula, the true formula for lactic acid, is C3H6O3.